This video is brought to you by Sporlan, quality, integrity, and tradition.
We got a call on this office AC. We've done some work on this fairly recently, but office AC not working, and the thermostat is blank. So the manager tried to do some of their own troubleshooting, and it's actually kind of smart. What he did, they have like 9 or 10 thermostats right next to each other, and they're all the same. So he had a blank thermostat, so he took the one that was blank and swapped it with another thermostat to see if the problem would stay with it, and it did. So it's kind of a cool little troubleshooting thing he did. Now, yeah, he could have caused some problems too, but whatever. Just shows that he's interested in, trying to troubleshoot before he calls. So we come up here and we're gonna test power. So let's go over here and let's see what we got going on here. So this is a 3-phase unit. You've got a 3-phase disconnect right there, but it comes into a contactor. So we're gonna go ahead and test 3-phase. Let's see what we got. So line 1 to 2, 197 volts, okay? 2 to 3, 196 volts, okay? 1 to 3, nothing. All right, now let's test the ground. Line 1 to ground, 113. Line 2 to ground, 113. Line 3 to ground, 113. So that's interesting. So we're missing a leg when we check phase to phase, but we have 3 legs to ground. It's a very interesting little problem we got going on here. So let's go ahead. We know I didn't want to turn anything off until we kind of looked, so we checked it. So let's go ahead and turn it off, and we're going to test the disconnect switch and see if we have 3-phase power coming into it. All right, so you're going to go phase to phase across the top. 197, 1 to 2. 2 to 3, 194, that's kind of weird. 1 to 3, 195. That's interesting. Okay, so let's go ahead and test our fuses now. So we're going to turn the meter on continuity. We're going to go across the fuse. Continuity, okay. There you go. Nothing. So it must be backfeeding from something else that it's connected to, is why we were getting a leg. So we've blown a fuse, all right? Now we need to figure out why we blew said fuse and where the potential problem is. So what we're gonna start by doing is testing phase to ground. So let's go ahead and find a good ground, and we'll use this one right here, and we're gonna test to see if we have any direct shorts to ground right here. Nothing. We'll test all 3 legs. Nothing. Nothing. Now, that's just the line voltage side. Now we need to test the load side of that contactor to see if we've got any shorts to ground there too. All right. Nothing. Nothing. Nothing shorted to ground. All right, so we're gonna do a visual inspection, and that contactor looks to be in really bad shape, but we don't know if that's the problem. So let's go ahead and we're gonna open up the electrical. We're gonna spin the condenser fan motor. We're gonna look for anything that would potentially cause a fuse to blow. So we went ahead and spun the fan blade, and it spins freely, so it's not locked up bearings. That doesn't mean there's nothing wrong with it, but that's a good check to see if you got anything locked up. And then we got our compressor right here. Nothing crazy going on in here. I mean, it looks fairly okay. We'll go ahead and test that capacitor. High pressure control's not tripped. Looking for anything that would cause a fuse to blow. Fuses don't just go bad. They typically go bad because something happens, so that's what we're looking for. We got our condenser fan motor capacitor right here, and it's a 7 microfarad, which is odd. Usually you see 7.5 these days. So let's go ahead and test this guy and see what we get. Definitely testing low at 6 microfarads, but we don't know if that's the cause, So let's go ahead and put that back into play. And then, so there's no direct shorts to ground on the contactor side, on the load side or on the line side. Nothing's jumping out at us as far as electrical shorts or anything. At some point we're just gonna have to change the fuses and turn it on. But before we do that, we wanna pull the Molex plug from the compressor. We're gonna test direct shorts to ground there. And then we'll go look at the indoor blower motor and look at that too. So nothing to ground on the Molex connector or the plug for the compressor. So that looks fine. So let's go ahead and do our compressor terminals to the copper line. Nothing. Okay. Nothing. And nothing. Now let's go terminal to terminal. .2, okay. 1.1. We're not getting good connections. So it looks like it's 1.1 all the way across. So don't see anything wrong there. Let's go ahead and plug the compressor back in. And then we're gonna pull apart the indoor blower assembly. All right, in here, indoor blower motor spins, no problem. Capacitor's up here, not the greatest looking thing in the world. Not seeing anything crazy. I don't like this economizer wiring, but I don't think it's even being used. Yeah, it's just sitting down in here. That's not even hooked up. Yeah, your economizer plug's right there. So nothing's too crazy in here. I mean, no burning smells. Everything looks fine. So we'll test this capacitor and then we'll change the fuses and see what happens. All right, we tested everything to ground, no direct shorts to ground. We couldn't find any rubbed out wires. We tested the line and the load side of the contactor. We spun all the motors, nothing's locked up. At this point, it's time to change the fuses. So we changed the fuses, put 3 good fuses in there, and we're gonna fire it up and see what happens. See if anything blows up. Push in the contactor. Condenser fan motor's running. Compressor's running. This is gonna suck because this is gonna be one of those intermittent problems. Now we know the capacitor's like 15% low on the run cap. We know that's a problem, but I just wanted to see if we can make this fuse blow again. Okay, we're gonna jump the unit out because the thermostat's gonna take forever, and we're gonna watch a full call for cool and then see if we catch anything else. All right, we jumped out from R to Y1 and to G for the fan. So everything should turn on when we fire this guy up. And it is. So now we're gonna let the system run. We're gonna start testing current of all the motors to see if there's anything funky going on here. Okay, condenser fan motor is allowed to run 2 amps. We're right at the money. We'll see if it goes higher as it runs. We know capacitor is going bad though, so we definitely gotta fix that, okay? Indoor blower motor, I think is this one. Yeah, we're allowed to run 4.7 amps. So nothing is over amping. The compressor itself is running 11 amps. I don't know what it is, but that doesn't sound too bad to me. Total unit load, let's see what the total unit load is at the moment. 17 amps, that's not bad. Got a 30 amp fuse in there. Interesting. We're gonna let it run. We are running low voltage though, because we're right at 197, 196 volts. So that's right at the threshold of being too low. Okay. I don't know if I have a capacitor for this guy. Been running for about 4 minutes or so. The current on the condenser fan motor is fluctuating. 2.2, 2.4, 2.0. Granted, it's allowed to run 2 amps, and our our capacitor is low. So this is one of those things, we know the capacitor needs to be changed, bottom line. We know that, but is that the problem? See, because it's not doing whatever it was doing in front of us. So sometimes you have to make an educated guess. We're running low voltage. According to the data plate, the minimum voltage is 197 volts with these units. We're running 196, 195. So we're on the low voltage threshold of it becoming a problem. Now I'm kind of curious why they say minimum voltage is 197, because I mean, you have an ignition module, but you don't have microprocessors. Typically, you'll see voltage restrictions that high. Usually 187 is the lowest, but for a 208 volt circuit, but this one's saying 197. So I'm kind of intrigued by that. I see that if you have VFDs or microprocessor controls, that they don't want you running any lower than, you know, like 190s, but not on an old unit like this. I'm kind of intrigued why they have the voltage limitation at 197. So we're definitely going to need to leave it running, and we need to go get a capacitor. I don't think I have I know I'm not going to have a 7 microfarad. We're probably going to have to go with a 7.5. Let's see what that does for us. Look at that voltage, man. 193, it just keeps dropping. Let's do, you know, one thing I wanted to check too, because the contactor kind of looked burnt to me. Let's do a voltage drop. Nothing. Nothing. So no voltage drop, but the voltage is definitely getting low. All right, we got a new capacitor. We're gonna throw it on real quick, and then we'll probably look into that contactor too. So this contactor looks pretty charred back in there. Again, we're throwing stuff at the wall to see if it sticks, because we don't know what caused the fuse to blow. I mean, everything's running, it's working, everything's running where it should be as far as current goes. No shorts that we can tell or see. So we're just kind of, you know, knocking out the obvious. Bad capacitor, contactor that's got burn marks in it. We've got low voltage, so that's going to amplify any problems whatsoever. So I showed this on social media a while back. I don't know if everybody saw it or not, but if you have a contactor that has lugs, if you pull the set screw from the lug out on the Mars ones, there's another screw, you pull that out, it'll accept normal screws. So I didn't happen to have a contactor with screws, but I had the lug one. So if you just take out the screws from this one, put them in this one, you're good to go. So life hack. Look at the current after we change the condenser fan motor capacitor is much better, 1.8 now. And we changed the contactor too. Let's get a total unit current draw right here on this pink one. See what the total current draw is. 17.3. So okay, there's not really much more we can do. The unit's working. We're going to check TDs, just make sure. We're going to let it run for a few minutes, but other than that, it's doing everything it can. So we probed up on the system. Everything is looking great, not seeing any problems. 15 degrees superheat, 12 degrees subcooling. Pressure targets are on point. Outdoor air is about 100 degrees. Approach temperature 9 degrees. 17 degree temp split. The airflow is off. We probably don't have the setting correct for that. We got to change the tonnage. So if we go to system info, change the tonnage to a 4-ton, and then hit save. There you go. If I remember right, this one's airflow was a little wonky. Yes, not too bad. That's about right on point. I don't see anything wrong with this unit. It's a 4-ton, 48,000 BTUs. I mean, everything is pretty much on point. I mean, you can't really ask for much better than that. Superheat target's about 10 degrees. We're running about 14. That's not too bad. I'm not seeing anything else that we can tell them. I'd love to do more stuff, but I mean, it's working. So again, we're gonna have to just give them a disclaimer. I'll probably leave this work order open for a couple days. We don't know what caused the fuse to blow. We changed the fuses. We changed all 3. We're gonna put 3 spares in there. We changed the contactor because it was looking worn out, and the run capacitor for the condenser fan motor because it was low. It was about 15% low. Other than that, everything else checks out okay. Condenser fan motor's amping correctly, indoor blower motor's amping correctly. We haven't been able to, it's been running all together with the time us going to the supply house. This unit's been running for at least 2 hours straight. So, I mean, I can't really waste any more time. I'll just leave the work order open for the rest of probably until next week, because it's Thursday right now. It's Thursday, July 22nd. So we'll probably close this out on Monday, and just we'll call them and make sure it's okay, and then close it out. And that's pretty much it. That's all we can do on this one.
This video was actually, I was looking at the footage. I forgot about this one. This was from Thursday, July 22nd of 2021. So, because I was like, what? I don't remember being there in July. And then I was like looking through the footage and the properties of each video clip, and I was like, wow, that's from 2021. Go figure. So, you know, we run into this stuff quite often where you just have a fuse blown, right? And I am not the type of person to just throw a fuse in there and see what happens. I like to take the whole big picture approach and go through everything, test everything. I have a story from many years ago. I've told it many times about resetting a breaker, and then of all things, when I reset the breaker, it had a grounded compressor. It tripped the main, and the main wouldn't reset. The main fried when it tripped. It was already going bad, I'm sure, but still. And then that restaurant, it was a disaster. Okay, so I learned my lesson on that one. I don't just change fuses. Now, another thing, people are going to say this because every single time I say this, but I stand firm to this. Fuses don't go bad on their own. Something caused them to go bad. Okay? I know there's going to be one or two people that say that fuses can gradually break down over time. Okay. If we go out there and we tell everybody that there's a possibility fuses go bad, everybody's going to run with that crap. And they're just going to be changing fuses left and right, right? Treat it as if fuses don't go bad by themselves, okay? It's easier to work that way because then you're always looking for something. And then if you don't find something, then so be it. But you did your best to try to figure out why the fuse blew or went bad, okay? So I went through the system. I checked everything, okay, as best as I could. You guys saw me methodically go through everything. We found a bad capacitor for the condenser fan motor. We found a contactor going bad for the compressor. Both of those things theoretically could have caused the issue. Low voltage to the unit causes weird things with these things too, with these units. But we do our best to try to figure out what's going on, okay? Once I probed up on it, you saw the pressures were like brilliant for 1990s Lennox unit. I mean, it's doing great. Everything seems to be working as best as possible, okay? There's not much more we can do. We just do our best, okay? But it's so important that we don't leave any stone unturned. We do our best to go through everything, okay? On the plus side, this was filmed in 2021. I haven't been back on that unit since, okay? Haven't even been back. I think we might have cleaned the condenser or something like that. But yeah, that's it. I really, really appreciate you guys making it to the end of the video as usual. It's so awesome. If you haven't already, please consider subscribing to the channel. Also, you can check out my website at hvacrvideos.com. We have merchandise available on there if you're interested in purchasing some. You can help support the channel. A couple other ways to help support the channel is via PayPal, Patreon, YouTube channel memberships. There's links in the show notes of this video for any one of those things. Another great way to help support the channel is via TrueTechTools.com. TrueTechTools.com is a tool website. I have an offer code set up with them. Big picture, one word, okay? You get a discount on checkout on almost all the items. There's a few things that doesn't work on, but for the most part, you get an 8% discount. I get a small commission from that. It's another great way to help support the channel. So check out TrueTechTools.com. And that is pretty much it. I do want to leave you guys with one thing, and I try to say this as much as possible, is remember to be kind to one another, okay? Everything's crazy right now, and you just never know what the other person's going through. That other person that was being a jerk to you very well could be having the worst day of their life, right? Not justifying them being a jerk, but you just never know. So have patience, be kind to one another. I really, really appreciate you, and we will catch you on the next one.